Alright, year 11s again, back again. I'm doing question 10 and 11 of exercise 3I. Mainly just to help you do the next three questions like 13, 14, 15, 16, 17. If you watch each one and you're doing them, hopefully by now you'll sort of get an idea what you need to do. One of the things that you should pick up is when they use rational solution, they're really trying to say that your discriminant needs to be a perfect square. Okay, and perfect square is anything that you have squared. Yeah, that's a perfect square. But anyways, let's go with question 10. Find the values of p for which the graph, so you got this, crosses the x-axis. Now, if it crosses the x-axis, it doesn't touch. Crosses the x-axis implies that you have two x-intercepts. Okay, that's the only way for a graph to cross. It has to cross here and then cross back, right? Touches, on the other hand, implies that you only have one x-intercept. So what that's really saying there is they just want you to show that you have discriminant greater than 0. That's the only time you're going to have two x-intercepts, right? So my equation, y equals px squared plus 8x plus p minus 6. Again, same thing, you need to find your discriminant. So b squared minus 4 times a times c. This is my a term, this is my b term, this is my c term. Right, so b, which is 8 squared, minus 4 times a, which is p, times c, which is p minus 6. That gives me now 64 minus 4p squared, and negative 4p times that, that's plus 24p. Right, rearranging the equation, I can take out 4 as my common factor. I'll take out negative as well, so that becomes negative 4p squared. What's this? And that becomes minus 6p. Okay, negative 4 times negative 6 is that. And then 4 times 1, that's 1, 2, 16. Minus 16. Am I right? 4, 2... Wait, no, that doesn't make sense. Is it? No, doesn't make sense? Wait. 1, 2, yep, no, negative 16. Cool, so I factorized it. So this is my discriminant. What I wanted was, I remember I wanted two x-intercepts, so I need the discriminant to be greater than 0. Okay? So again, you're going to sketch this graph here, and if you sketch it, it makes it much easier to sort of see. But before I do, I'm going to see if I can factorize it further. So this is what, p bracket p. Let's see if I can factorize it further before I sketch. So 16, maybe 8 and 2. 8 times 2, but if I have negative 8 plus 2. There you go. That works. Negative plus 2, and that gives, yep, cool. So that already implies that the graph, if you were to find out the x-intercept, y-intercepts, you can already see, to find out the intercept, sorry, there we go, discriminant by p, we can already see if you want to find the x-intercept or x-axis intercepts, clearly discriminant needs to be 0. That's on the x-axis. Yes, I'm just saying anywhere on the x-axis, discriminant is clearly 0. So if it's 0, well, let's work this out. You got negative 4 bracket p plus 2, p minus 8. So clearly using null factor law, you can see that it's negative 4 times this magic box times this magic box, and one of it has to be 0. So this is p plus 2 needs to equal to 0, and this is p minus 8 needs to equal to 0. So let's work it out. P plus 2, if it was to equal to 0, p would be negative 2. And p minus 8, if it was to equal to 0, p has to equal to 8. Okay? So what that tells me is that I know that when p is, I'm just going to rub this off, p is negative 2. So when p is negative 2, discriminant is 0. That's what I just worked out, yeah? I said when discriminant is 0, I just worked out p has to be negative 2 or 8. So let's say 8 is over here, so that's when 8 is your p, discriminant is 0. And I know it's a positive graph, so because they're right here, the value, actually it's not even a positive graph, my bad. It's a negative graph because there's a negative here. Negative times p squared makes it negative 4p squared. So you can tell it's a negative graph, so it should look something like that. Okay? We're not interested in the y-intercept and the turning point. We don't really care. We just want a general graph. And remember, it says when is the discriminant greater than 0? And clearly, this is when the discriminant is above the x-axis, which means that's when it's greater than 0. And you can see that, well, the values that it would have to be any p-values between -2 and 8 will guarantee that you get a discriminant bigger than 0. See, they all correspond to a positive discriminant. So really the answer is p has to be bigger than -2, but it has to be less than 8. True? Now there is only one little flaw in this, and there's a problem, okay? It is true that any values you choose from -2 to 8 will make sure that you'll have 2 x-intercepts, but there is a problem. The number at p equals to 0, see, p equals 0 is here. That's the spot. When p equals 0, yes, you do have a positive discriminant, but be careful. See, when p equals 0, look at the equation. If p was 0, then what you end up with is you get plus 8x minus 6. True? That's what y will equal to. So that's not a quadratic equation anymore. That's a linear equation. So therefore, you can't consider that as part of a quadratic answer. So this should be your answer here. You should say p can be -2 to 8 anywhere there, and it will always work where you get 2 x-intercepts for this quadratic equation, okay, except for p equals 0. So you don't want p equals 0 in there either. Okay, and that's for question 10. Just to be mindful of those because they come up quite often. Just be careful. The coefficient of x squared, you can't have that equal to 0 because then you won't have a quadratic equation. Sure? Now, question 11. Let's have a look at question 11 now. I can't seem to move. Oh, there we go. Question 11. Let's have a look at question 11. Show that the equation, okay, so then you got p squared plus 1 x squared plus 2pq times x plus q squared has no real solution, so no x-intercepts for any values of p and q where q can't equal to 0. Okay. So you just basically want to show that there's no real solutions, meaning no x-intercepts. No x-intercepts implies that discriminant is less than 0. Yeah? Discriminant, on the other hand, is b squared minus 4ac. So my b, again, at this point, I'm just going to highlight them all. My b is 2pq, my a, which is p squared plus 1, and my c is q squared. Okay? So if I were to write this down, p, that's 2pq squared, minus 4 times a, which is p squared plus 1, times c, which is q squared. Yeah? Expand all of this, you get what? 4p squared q squared minus, again, 4p squared q squared, and then minus 4q squared. Oh, this is convenient. Did I do that right? Let's do -4 times p is -4p squared times q is that. -4 times 1 is -4 times q squared. Okay. And this nicely cancels out. So discriminant is equal to -4q squared. Oh. Well, in this case here, it says show that the equation has no real solutions. Oh, okay. Now, if we sketch this, okay, if we were to sketch this graph, discriminant by q, okay, what you can see is this is a turning point form where this is your a value, that's your negative graph, so it's negative and it's narrow, doesn't go up or down, and it doesn't move left or right. So I already know it is just negative q squared, like that. That's what it looks like. Okay, and that already tells me, it means that it doesn't matter what number you choose for q, you can see that the graph is always below the x-axis, except for right at this point, right at that point, when q equals 0, on the other hand, then you get discriminant equals 0. But if you get discriminant equals 0, it means you have one x-intercept. Sure, but that's what they don't want. They said they want to have no x-intercept. So this is a problem. Q can't equal to 0, because if q equals 0, discriminant is 0, you get one x-intercept. And that's why, if you have a look, it says q can't equal to 0. Yeah, but p can be anything. P can be whatever they want. It doesn't really affect it because at the end of the day, p is going to cancel out. Okay, so that's why, so you can see from the graph that since discriminant is negative 4q squared, it will always have no solutions. Okay, it doesn't matter which value you choose. The coordinates are always corresponding to a negative discriminant. Hence why it's always going to be no solutions. Okay, it doesn't matter what q or p you choose, as long as q doesn't equal to 0. And that's how you answer question 11. Okay, so you'd say from the graph, the graph for all q values except when q equals 0, the discriminant is less than 0. Therefore, it has no solutions. Okay. There you go. That's question 10 and 11. Hopefully that helps, and I'm going to leave it there. I reckon you should be able to do now question anything onwards, but watch all these videos again. Try to make sure you get your head around exercise 3I. It's very important. You can see how I'm just using all the skills that you've learnt so far, learning how to sketch, learning, that it doesn't have to be y and x variables. It can be discriminant and q, but to read and analyze what it means, that's exercise 3G. Expand and simplify, this is exercise 3A. Some of the skills you need is like factorizing, so 3B, solving, 3C, reading the turning point form, which is this one here, that's 3D. Prior examples, like I think it was question 7 or 6, you had to complete the square, that's 3E. 3F is to sketch, see I sketched in this equation here, I sketched in this equation here. 3G is the in equation, so it's less than or greater than 0. That's where I highlighted, so that's 3G. 3H, which is your quadratic formula, that's where the discriminant comes from. So that discriminant there comes from, the quadratic formula, 3H. And then now we're in 3I. So you can see everything is tied together. You don't get the basics, you'll find 3I really hard, which is why I've been pushing for you to do your homework to make sure you get your understanding of the basic skills. Yeah? Alright, I'm going to end the video here. So here we go.